So for this first number, this one should be, what, 17?
Yes.
This guy should be 12. This guy should be 35, right? Okay. There we go. And our slope here every single time is plus 3. Does not change. Our slope here every single time is take away 2, negative 2. And our slope here every single time is plus 7 every single time. So a linear relationship is a relationship where what is true? Go.
Where your slope is increasing, is changing by the same number.
No, your slope is not changing by the same number.
I mean,
You mean,
it's constant.
yes, a linear relationship has a constant slope. I'll give you a minute to write that down. Okay? Okay. At the bottom, so this guy is 12, this guy is negative 8, and this guy is 28. Thank you. So this is two things. It's linear. Who, pull a name, please. Jessica, why is this linear? Do you know why? Okay. Let me show you this. The slope here is 3, 3, 3, 3. The slope here is negative 2, negative 2, negative 2, negative 2. The slope here is 7, 7, 7, 7. Why is this linear? Jessica. You're exactly right, because the slope is constant. It does not change, it stays the same. It's also proportional. Now, who can tell me, actually, all of you should be able to tell me this. Tell your partner right now, how do you know that this is proportional? Hisham, why is it also proportional?
Because the y-intercept is 0.
Exactly, because the y-intercept is 0. I'll give you a minute to write that down. All right, so the quadratic one, the slope is 2, then 3, then 4, then the next one should be 5, which makes this missing number 16. The slope here should be 2, then 6, then 10, then 14, right?
For the first one, it's
Oh, sorry?
it's 6.
Oh, I'm sorry, because we're not adding, we're taking away. Thank you. So that's 6. And then this guy should be 32, right? Okay. And then this is add 10, add 8, add 6, and then add 4. So 28. Am I okay there? So on all of these, if you look at this pattern in the slope, like this slope is decreasing by 1. This slope is increasing by 4. And this slope is decreasing by 2. So who can tell me what makes a quadratic relationship quadratic? Hisham?
Or because like the slope is changing by the same amount.
Yes. Quadratic relationships have a slope that changes by the same amount. So for example, like this is decreasing by 2, this is increasing by 4, this is decreasing by 1. I'll give you a minute to write that down. So the exponential, This one I'm timesing by 4, timesing by 4, timesing by 4. I don't know, what is 64 times 4? 256?
Yes.
Oh, I'm impressed with myself. And then this guy, I'm timesing by 3, timesing by 3, timesing by 3, timesing by 3. What is it? Okay. And this guy is times by 2, times by 2, times by 2, times by 2. 28? No.
120.
Oh, yes. So, exponential relationships. Who can define what makes an exponential relationship exponential, Katrina?
When the slope multiplies divides by the same number.
Okay. And it's actually not called slope anymore. It's called it's called a growth factor. When you're multiplying or dividing, we call it the growth factor. When the growth factor which is the number you multiply by, stays the same or constant. Okay, I'll give you a minute to write that down.